Good morning. My name is Khoa and my partner name is Shar. Our project is called Shower Power, and our motto is a power through your showers. All right, so who are we? We're both 20-year-olds. We're best friends. We met in college. We both like to play games and be weirdos together. Shar is majoring in electrical engineering. I am majoring in biomedical engineering. Um, Shar is going to UCLA next fall. Just a flex. And we both enjoy taking long showers, but neither one of us enjoy spending too much money. Alrighty, so our team roles. I was in I'm in charge of doing the basic research, the outline, materials planning, the draft part list, and draft budget, and the overall report. And Shar was more of the mechanical guy, doing the circuit and writing the code, building the unit testing. We both did the research, and he did the material planning. Alrighty, this is a happy cat taking a shower. Alrighty, so from our survey, we found that 88% of the people don't know how much they are paying for their shower bill until after the month is finished and they receive their overall water overall water bill. So what are we presenting? We are presenting a device that will make long showers feel better because we will know how much we are spending, and the device will help us track how much we are spending right on the spot. The, the issue is that we don't know how much we're spending and how high the water bill will be until the end of the month. So after the damage has been done, after our pockets has hurt already.
So the device that we propose to solve this issue is an Arduino-powered meter that hooks onto your shower head. During your shower, the device will show you how many liters per second you're using, and when you're done with your shower, you can press the button on the front panel and it will show you some statistics, such as time elapsed, the cost of your shower, and the amount of water you used altogether. Although the battery life is rated to be 26 hours, when charging is needed, you can plug a USB-A to 3.5 millimeter male into the device and it will be charged. Our target market covers several types of people, but most specifically, we're more targeting towards anyone who wants to save money on their water bill and wants to become more conscious of where they're spending their money. Additionally, anyone who is environmentally conscious could be interested in the device in order to see if they're able to save some water.
So
And
for
here are our human factors.
which are social, we are addressing social, emotional, and cultural.
So here is our timeline slash Gantt chart. Um, it's pretty much done, but if you look at the build entire unit and testing, those are the only two areas that are kind of behind. And I'll be going over that later when we're talking about the actual unit. So here is our purchasing report. Um, yeah, this is pretty much all the parts that we used. And then that leads us into our per chart. So the stage that we're currently at is in between the test again slash end part. Um, we just need to test our project more. As for the technical specs of the device, the key components are the waterproof case, the flow sensor, and the boost converter. The flow sensor has a rotor inside of it that rotates depending on the amount of water that flows through it and produces a pulse. And we were able to read this pulse in the Arduino unit to calculate the amount of water used, as 450 of these pulses produce a liter. The boost converter allows us to step up the 3.7 voltage from the lithium ion battery to 5 volts that's required by the Arduino. And here are some sketches from the very beginning of our project. And now we have the statistics on our device.
Okay, so this is the survey analysis. We found that 96% of people enjoy taking showers, because I sure hope so. You want to be clean, don't you? That was our first question. Do you enjoy taking showers? And I guess the other 4% are just people who enjoy being dirty, which is fine. For our second question, the question was, how long are your showers? So we gave the choices of 0 to 5 minutes for that 4% that don't enjoy taking showers, 6 to 10 minutes, 11 to 20, 21 to 30, and over 30 minutes. So 81% of people enjoy taking showers that are actually longer than 5 minutes, which is, I say, a good amount. I feel like anything under 5 minutes is not scrubbing all the nasty things off of you yet. And then our next question was, do you think your showers are too long? So a majority of people actually said no. That is because they don't know how much they're spending. Thus, our device will show them. Leads to our fourth question. How many days do you shower per week? Most people shower every day. A small percentage of people shower every 2 days, which is acceptable. And unfortunately, there are people out there who shower once or twice a week. But it really be like that. It's quarantine. And then, do you know how much your shower costs? Was our fifth question, and 89% of people don't know, because most of us most likely are still living with our parents, and in fact, our parents probably don't know how much each shower is costing until the end of the month when all the water bill adds up. So if they answer no to question number 5, we asked them, would you be interested in learning more about our device that will show you how much your water costs? And 70% of people that we surveyed said yes. And I think our device is pretty awesome. It's pretty interesting. I think the other 30% was just our competitors who like are jealous and want to bring us down, but that's okay. Shar and I are like the duo team, so we push through. We flex on them haters. Which leads to our question number 7. How interested would you be in a small device that calculates the cost of your shower? And this is where we found that most people are interested, which is a good thing. Alrighty, so that wraps up our survey analysis showing that um, most people take showers, and the people who do take showers don't know how much they're spending, meaning our device will be very helpful to them.
So we are able to summarize our findings after analyzing our data. So the cost breaks down to 5710 for all the components that we needed. The theory behind our project is simple. We just needed a way to calculate the way we break down the cost. We get the cost per liter from PG&E and the number of pulses from the flow sensor, which is iterated in our code. To break down the liter number, we divide the overall number by 450, as there are 450 pulses from the flow sensor into 1 liter. So this is our device. All the wiring and soldering is complete, and all that's left to do is mount the internals into the case when it arrives. Unfortunately, the case still has not delivered, even though we ordered it during the first week of July. I ordered another case, I think either last week or the week before, and that hasn't shipped either. So to prevent water from short circuiting and nuking our circuit, we decided to hold off on testing until that case arrives. We could then successfully test our device in a real setting without short circuiting. So if you look closely on the left, you can see the flow sensor. And I decided to desolder the jumper female jacks from the flow sensor, and I replaced it with a 3.5 millimeter jack. This is because of the water that'll be dripping onto the cable, so I wanted to make sure that water does not cause a short and fry our board. So here are some snippets of our code. The setup function is really straightforward. We're just initializing the pins in the LCD screen. The loop is where we're taking care of the actual showering portion. So we store a boolean in the code called mode, set to true or false, and it represents if the user is in the shower currently. If this mode gets changed, we have two cases, starting shower or ending shower. In the first case, we print out the rate, otherwise we print out the cost. After that, we take care of finding the price and the rate of shower. We also determine if the shower is off by using the count of the flow sensor. Since we're iterating the count of pulses from the flow sensor, we check to see if the updated count is the same as a previous count. And if it is, then the shower is off. And this is the final product of everything coming together and working. All we need is that case.
And so now, if you buy our device, you can be happy and your pockets can be happy, like this little happy dude showering. So, overall, this project was really fun because we were able to work together as a group of best friends. We did something useful with our time and built a device that's helpful instead of just playing games all day and simping. But now we know how much our shower costs. Our parents are paying for the bill, so they will be much happier knowing how much they're spending right away. So shower through your power, and that's our device. Thanks.